So again, this is sort of a, an overview of really those fundamental things that Zach was mentioning.
Mhm.
So when you start out fresh, you can create a project. I'll call this CSC, and again, ask me questions where they are. I mean, I think that's good for all of us to review. And then in your project folder, by default, you get a source folder, and then within the source folder, you can create a package. You can call this your programs. And then within your programs, we can start now. So I'll start with the basic, like, the person class, right? If we're looking at a person, right, we're modeling a real world person, right? So we'll have a few things, right? So the first thing could be, let's say we have, so we always the template is instance variables, constructors, and does anyone else know what I'm missing here?
Static methods?
Non-static methods, actually.
Non-static methods.
Yeah. So my instance variables for a person, I could say, well, the most basic case is to have a name, right? And so, okay, I'll make it private. It'll be of type string, and then it'll be a name. And then I can build this idea further by saying, okay, well, I'll have a person constructor. And inside this person constructor, so what does a constructor do? Do you guys know?
It's a blueprint for building objects.
So the class is a blueprint for building objects, the entire classes, right? And the blueprint, the structures, you'll have instance variables, you'll have, see, the thing is, like, you can think of like a blueprint for a car. The car will have certain attributes, things you can describe it with. And then, it'll have functionality like drive and so forth. And those could be your methods, right? So the whole thing is a blueprint. The constructor, it sets the default values for the instance variables, right? So the default value for the name would, whenever we create a new person, could just be an empty string, right? And then we'll have, let's say something to set the name, right? So we'll say public void set name. Now the set name should be void, as I said, yesterday, because we're not expected to return anything. But should we pass anything in here? Do you guys think? Or just, yeah, we would have to pass in the thing we want, right? And so we would say, okay, well, this dot name is equal to new name, or you could call this name as well. That would achieve the same outcome. So this is a very basic class that I'm building here. And then you could have a public, string get name, and I put string there because I'm returning a string now. And what do I return here? I return this dot name, or I could say return just name, I could say. And so this is it's an extremely basic blueprint of a class, right? I'm just keeping one instance variable, a constructor that defaults that one instance variable. I have a setter and I have a getter. So this is sort of that raw view. Now, another thing that might be confusing is the equals method. Do you guys remember what the equals method does?
The dot equals. That's comparing two things to see if they're exactly alike.
Yeah, exactly. Yeah. So we'll do the dot equals, but I just wanted to add something else. This is sort of a constructor that doesn't take anything, but in addition to that, I could have a constructor that does take something. I can actually have the user pass in a name if they wanted to. And so this allows them to pass in that name initially. And then I'll say their name is actually the name that was passed in here. So back in my main method, and you know what a cool trick is, you can actually just have your main method here. I won't do that, but I could. I'll just do it here. Public static void main, and then string, then arguments, just so that we can demo this while we build it, just so we know what's happening. So I can actually create my person. So I'll say person p1 equals new person. Okay. So I have an option here. I could just say, I could say this, or I could actually pass in the name I want. Like I could pass in John. So do you see why we have this other constructor?
Yeah.
Okay, because it allows us to do that. If I didn't have this, yeah, constructor overloading. If I actually commented that out, this would give me an error, and it would force me to actually, it would change the constructor parameter to string. It would be like, you have to have a string inside here to do it. And so you actually, it forces that to happen. Okay. So constructor overloading. And then I can say p1 dot set name. I could say, well, I mean, I don't need to set the name anymore, but if I didn't have it here, then I would have to, right? So I'd say p1 dot set name. And then I could say John, right? And that's kind of, and then I could say system.out.println. And then I could say p1.getName. Okay, and then we'll print this out. So when you create it, test things before moving on, and then I get John. So everything's working. I could have a toString, right? Public string toString. Okay. Public string toString, or yeah, public string toString, and then it's going to be like, okay, well, you return the instance variable, right? So you say return, your name is name. So are we good so far? So if I do, system.out.println, if I do p1.toString, you can see I printed out John. Does someone have a question? Someone say something? Okay. So yeah, so now let's move on to the more complicated piece, the equals method, right? Now, the idea here is, like Carol was saying, you compare two objects if they're equal. So public Boolean, right? Because you're returning a Boolean because you're going to return true or false, right? Whether or not it's if it's not the same person or if it is. So public Boolean equals. So the idea here is to say, okay, well, object, other object. So object, all objects in Java are of type object, because they're like all objects are polymorphic, like they all extend, all objects extend from the object class. It's like it's the prime parent of every object that you could create. So if I say extends object here, that's fine. Like, me doing this doesn't actually change anything in actuality, because all objects extend from object. So if I don't have it here, it doesn't give me an error, because, well, all classes extend from object. Why specify it? But I could. And so what you're doing here is you're passing in a random object into the equals method, and you don't really know yet if this other object is of the type person, right? So the first usual check is to say, okay, well, you'll have a Boolean variable. You could call it, are they equal? You could set that to false, let's say. Initially, you'll assume that they're not equal. And that's common practice. So the idea is that if the other object that was passed in, if it's not null, because if it is null, well, they're definitely not equal. Am I right? If it's null, then they're definitely not equal. So if the other object is not equal, and this other object is an instance of type person, then we check for equality. So does everyone kind of see what I'm doing here? Do you see what this instance of set means?
Yeah, because if it's not in the person class, then it's not the same.
Yeah, exactly. Like an instance just means like an occurrence of something. So like it's something that like I've came up with this new object. Is this an occurrence of the person? Like is this a person? So if the other object isn't null and that other object is of type person, then I can check whether they're then I have to do more checks. Now, do you see why I have to do more checks? Does anyone know why I do more checks? Like, why don't I just say, are they equal equals true, and then stop there?
Because anyone that is a person type is going to be true. You're trying to find a specific person to see if there's a duplicate of a specific person.
Yeah, absolutely. Yeah, I want to see if the two people I'm matching are the same. And just because I checked if the other object was null, And just because I checked that the other object was a person, well, guess what? Me and Carol aren't null, and we're both people, and we're both of type person, and yet we're different. So on the basis of what should I be comparing both of these objects? On the basis of what?
Instance, I mean, the data that's,
Yeah, the data. They're write their name and stuff, right?
yeah,
So what I'm gonna say is like, okay, well, hey, like this object's name, like this name is, well, what is it? It's the name we have here, right? Like we can say the get name, or we could just say name even, or we could say get name, or yeah, I think you could just say name. Right? I'm talking about this name. Like this object's name is just name.
mhm.
And then the other object, right? Or like the other name here that we're talking about, the other object's name. Well, actually, before doing this step, I think you need to create like the object itself. So, it's of type person, it's another person, and then you have to like it's the other object, but you have to typecast it, I believe, to person, right? This is a precursor. And why we do this is because eventually then we'll say other person dot, now we can get their name. You see why we created this? So it allowed us to handle their data, right? So like we have our name, which is just name, right? The name we have here. And then we have the other person's name, right? Which is other person dot get name. So that's why it was important to have this line up here, so that we could actually create an object whose methods we could access to then check for equality. Does that make sense? Does everyone see why I introduced this new line here?
I remember it from last class.
Yeah. So like if I didn't have it, then how would I access this other person's name if I didn't have it? Like I can access my name, right? This name, this object's name, me, my name. I can access my name by just name. But the other name that I'm talking about of this other object that I passed in, how am I supposed to access its name? Well, I create an object of that person type, and I typecast it to person, so that now all the methods that a person has, that other object has too. So I can say other person dot get name. Now, you see what I'm saying? So why it was important for me? This is a handle. This is a handle. You want to access its name to see if your name is equal with its name. Well, you have to have a handle on it somehow, right? And so this is the idea behind that. So I have my name and I have the other person's name. If the names are equal, so if this dot name equals the other person name, then are they equal is true, right? Otherwise, otherwise are they equal just never becomes true, and are they equal is false, or just return are they equal. So does everyone see how this method works? Do you guys see how that method works?
I think it's a complicated one, but this is line for line what it was from the previous one. So I would say keep going.
Yeah, well, I mean, I really want this to be as transparent as possible. It's definitely a complicated one, right? It's definitely a complicated one. But if I note out the template, right, where I'm talking about a general template here. So I have a public Boolean equals, not going to change. This won't change. Object, other object. This won't change, right? If the other object is null, and by the way, class that we're interested in, let's call this, the interested, or let's call this the concern. Like, let's just call this the special class that we're interested in. And in the case above, it was person, right? Okay, so if the other object is not null, because you can't compare them if they're not null, or you can't compare them if they're not null, or if they are null rather. So if the other object isn't null and the other object is an instance of the special class.
Mm-hmm.
Okay, so this is me just saying that, hey, if the other object is existent and the other object is of the type of the class that I'm interested in, then I can check if their instance variables match, right? So if they're both the same type, I can check if their instance variables match. And
Mm-hmm.
this is all that was happening here. I was getting the name, and I was getting the other person's, this person's name and the other person's name, and then I was checking if they match. And of course I had to create the object first. So I had to say, special class, I had to say special class other class equals so this is giving me a handle on it, right? So that I can start to compare. So that if I can say other class dot get name, I could say this. I could say other class dot get age, right? Because there's no way for me to access the name and the age or the instance variables of the other object if I don't have the ability to call these methods on it, right? I can't do dot get name or dot get age without at least having an object that allows me to do that. So does that make sense?
Yeah, so whatever class we're doing, like this one happens to be person class, but if we did book class, or if we did, sex ed, we might have a different class.
Mhm.
Then everywhere it said person, we would have whatever that class is.
Yeah,
Yeah.
without a doubt. And
Yeah.
if you would have passed in that book here, guess what would have happened? Well, like the person and the book aren't null, so the other object isn't null. But is the other object an instance of person?
No,
No,
it'd have
it's
to
a book,
be book. Yeah.
right? So then this would be false, right? Like we wouldn't come and check their attributes. So what this piece of code is saying is, don't check their attributes if they're not even of the same type. Like
Yeah.
I'm not going to compare my attributes with that of an animal because we're not even of the same type. You
Right.
compare a zebra with a zebra, not a zebra with like a human, right? So they both have to exist and they both have to be of the same type. Then you can go ahead and compare their eyes and their legs and so forth. And that's what we're doing here. We're comparing the eyes and the legs. So, but we're comparing the name and the so if I had let's try to modify this so that I also had an age. So I would have a string age here, right? And then I would say, okay, well, it wouldn't be a string, would it? It would be an integer, right? So it would be an int age, and then this dot age would be 0 to begin with, right? And then all I would really have to do is just add a getter and setter for the age. So I'll say public void set age. I pass in an age so that they can do that. And I say, okay, well, the age that is on the class level is also, of course, the one that I've passed in. And then I can get the age as well. So I'm returning an integer. If I want to get the age, I have to return an integer. And I just return the age, right? And now, like, I did check their names are equal, but what if they both have the same name, but their ages are not equal, right? So I have to say, and, right, the and the this dot age is equal to the other person dot age. So see how this other person object lets me like access all of the instance variables, right? Like this age, like my age, is my age equal to the other person's age? So if I didn't have this object, I couldn't access the other person's age. I can't access the other person's name, right? So, and again, you don't have to have so many variables in here. You could just say, is this dot get age, is that dot equals to the other person dot get age? You see what I'm saying? And let's see what, oh, some nesting error probably. What is going on here? One sec.
Do you have to, on the,
Mhm.
well, on the, on the overloaded constructor, do you have to have age there as well, or no? The second,
Yeah, this one.
no, down one
Oh,
more.
definitely. Oh, yeah. Because guess what would happen? Guess what would happen? If I chose to pass in their name.
It won't accept an age because you don't have space for an age.
Yeah, like, I mean, yeah, exactly. Like I can pass in a John, but if the person uses the overloaded constructor, well, it's never going to set a default value for the age. So that becomes a problem. So yeah, I would have to say this dot age is equal to age. But also the thing is, like, you could have them pass in that age here as well, right? You could say int age, right?
Right.
So now here it's telling me, hey, you got to pass in an age. So I'm going to say 13. Okay. So John's 13. And then we had a toString. So the toString does name, and then it gives you the name, right? But in addition to that, we could say name who is, and then we'll say age, years old, right? Okay. So now all I have to do is p1.toString. Now, if I print this, is anything going to be printed out? Does anyone know if I did that?
Do you need the scanner class and all that stuff?
Yeah, something like I would need the print statement, right? Because it returns a string, but I need to somehow print the string out, right? So I have to say p1.toString. Okay. And as you can see, now I get that printed out. Name John, who's 13 years old. Okay. So again, I'm gonna go through the next class extremely fast just because it follows the same format. So here, but now we're doing the inheritance. So the employee, guess what? The employee is of what type also?
Person.
Person, right? So it's of type person. Now, since it's of type person, okay, I'm going to have some instance variables. I'm going to have a private field. It's going to be an integer. It's going to be the employee ID. Okay, and then maybe I'll have, see, the thing is I could put name here, right? I could put name here as a instance variable, but why doesn't that make sense? Does anyone know why that might not make sense to do?
The person, you already get a name when you inherit from the person class.
Yeah, it's like a buy one get one free. Like you're doing the employee and you get the name for free because you extend it.
Yeah.
So I don't need the name. I don't need the get name. I don't need the set name. Okay, I don't need any of that stuff. So over here, all I will need is the employee constructor, and then so this gets interesting. So remember what I said for the constructor. The constructor does what? It gives you default values for the variables, right? So let's suppose I wanted to pass in a let's suppose I wanted to pass in the employee ID for the just the default value. So this dot employee ID is 0. But what about the name? How do I do the name?
Super.
Super, right? I just say super. And where does super go?
Right there.
Yeah, super does go right there, but it refers back to the constructor of the parent. Yeah. Right.
It was a trick question, sorry.
Yeah, no, it's okay. It goes right here, and then what does it catch? It catches a name and age. So automatically, employees have a name and age, right? So that's how that works. And then I don't need to do set name, get name for name and age. I get that for free. But here I can just say public Boolean or public void set age, and then I'll just have, I obviously again
Like employee ID, right?
yeah, set employee ID. And then I actually have to have have to pass in, this is the new employee ID that I'm concerned with. And then that the employee ID that I have up there is equal to the new employee ID. And again, this is up for preference. I usually just call them the same thing. Okay. I'm gonna breeze through this real quick, and then I'll have the setter. Or the getter rather. So just getter, and then that's just gonna return the employee ID. Okay. And I get a problem because, and do you know that chatbot, it will also tell you what's wrong with your code.
Nice.
Interesting. Yeah. Return this dot employee ID, and it needs to be of type integer. Okay. So, and then we'll have, again, this is the idea behind the, you could have an overloaded constructor. This is probably important. So how do you do an overloaded constructor if I want to pass in the name of the employee?
You have to override it with the exact same method heading, right?
Well, like, so I pass in this name here, but here I can't do what I did before. I can't say this dot name is equal to name. I can't do that, right? Because there is no this dot name up here, right?
Mm-hmm.
So how do I do this? Like, I want to pass in the name, but I can't do this dot name is equal to name. I can't do that.
Hmm.
So how do I do this? Does anyone know how I would do that? Got 5 people in here, or 4.
Not me.
No, Bishek, Kareem, Rowan. So what we do is we pass in the name to the super thing. And if the person has a constructor that takes in the name, then we're fine. See what I'm saying? So you just pass in the name to super receives the name, then we jump to person. We jump to the constructor that takes in a name. This constructor doesn't take in a name, so we're actually referring to this constructor here. Does that make sense? So we pass in the name to super, and super searches through constructors. It's like, okay, this constructor doesn't have a name, doesn't take a name here. This constructor does. So you see what I'm saying?
Mm-hmm.
So that's sort of the idea there. And so all these things are transferable to any class that you could probably make. And then your toString would probably be a little more complicated, right? You'd probably say, okay, well, public toString or public string toString, right? So you're saying return super dot get name. So this is kind of your name, because you don't have a get name in here. The super class does, right? So you say, okay, well, your name is this, and your employee ID is, or your age is this, right? So I can't get the name from the employee class, so I have to go to the person class. So super dot get age, right? So this is your age, and then I get to tack on something that's unique to employees, which is their employee ID. So the employee ID is see what I'm saying?
Mm-hmm.
So now, I can kind of do what I had over here. So this is, I'm going to call this E1 for employee, and instead of person, I'm saying employee instead. And then I'm saying employee here. New employee, right? And then the employee doesn't have a constructor that takes in a name and an age. It only has one that takes in an age, although we could change that, but it's all right. We'll just take in the name. And we'll say E1 dot toString. We'll see if this works here. You'll see that we have age is 0 and the employee ID is 0. So why is that? This dot employee ID, because we didn't set it, right? E1 dot set the age to be like, 29, and E1 dot get the age to, or not get the age, but set the name, right? To be, well, it should have done this up here.
Do the employee ID, right?
Yeah, but see, the thing is, yeah, E1 dot employee ID too. So what you'll notice is like the set name and the get name are not in the employee class, and yet E1 dot set employee ID. Right. So what you'll notice is that the set age and set name are not in the employee class, but because I extend person, they are in the employee class. In some sense, right? So I have I have name. His name is Jacob. I have to add a space here, right? His name is Jacob. His age is 29. His employee ID is that. So okay, so I have Jacob 29, employee ID 223, right? Okay, so that's kind of the basic outline of of classes and the equals method. If that makes sense here. Okay.
Mm-hmm.
And yeah, this is kind of pretty much all I can really think of in terms of, classes, right? I mean, this is kind of the extent of what we've done with classes, if I'm not wrong, like normal classes of people and different, real world entities and so forth. Everything else is like strict data structure, right?
Mm-hmm.
That's the idea there. I do unfortunately have to log off. I apologize. But
No, that's
yeah.
very helpful.
Yeah, this one's recorded. I'll send this up within, 30 minutes. And so you can watch this again.
Wonderful. Thanks a lot, Ram.
Yeah.
Ram, sorry.
Yeah, any parting questions, maybe? Any kind of like thing that you were thinking about that you didn't feel like you knew, and something I could real quick tell
No, I think I just got to chew on it a little bit, and then tomorrow morning I'm sure I'll have one.
you? Okay, yeah, for sure. Absolutely.
All right.
Awesome.
Hey, thanks, guys. I appreciate it.
All righty.
Thanks, Ron. Have a good night.
Thank you, bro.
Absolutely.
Sorry I came late. I didn't realize you guys did the Zoom until I checked my Discord.
Oh, that's all good. Yeah, all good. Yeah, you didn't miss anything.
Yeah.
He's gonna send out the recording. So
Yeah.
All right, perfect. Yeah, no, I usually like OBS it like sometimes just so I could get it like instantly and rewatch it.
OBS.
Yeah, like the Stream Deck thing.
Oh, okay. Got it. Awesome. Yeah, that's what's up. Yeah, I have it on YouTube, so you could watch it on there as well.
Oh, perfect. Yeah. Is there a link I should click?
Yeah. I'll go ahead and like it is in the Discord. I did put it in the Discord, but
Oh, okay. Yeah.
okay.
All right,
Awesome.
Perfect.
All right.
Thank you.
I'll see you later. Bye.
All right, see
all
you
right,
guys.
have a good night, guys.
Good night. Good
Good
luck,
night.
guys, tomorrow.
Yeah,
You too. See ya.
10 o'clock. Don't forget.
Oh
Yeah.
shit. Yeah.